Hey friends, Chris again. I'm hoping to do a really quick introduction for Docker here. I want you to get up and running with Docker as quickly as possible, so I'm just going to show you the best parts of it really. So first off, what even is Docker? Well, it's a container technology, and that is not terribly useful. When I was first looking into this, I didn't know what a container was. It's often contrasted with a virtual machine. You may be familiar with a virtual machine. I've got a quick video series on Vagrant, and that is all about building and running virtual machines. Container technology is a little bit different, and it's actually superior. I'll tell you why. Because when you run a virtual machine, you're really running this big giant process that is running an OS and everything, and your host machine doesn't really know what's going on in that VM, and it's rather slow. The difference, though, is a container. It's like a little sandbox that runs inside your own OS, as long as it's Linux. And so everything's really running on the bare metal on your host machine. So, if you have like an EC2 instance up on AWS, and you want to make the best use of that machine up on AWS or Google Cloud or whatever you have, if you run containers on that instance, they will perform better than if you carved up a bunch of virtual machines. So anyway, with all that said, let's just get going to a practical example. What we're going to run today is we're going to run Nginx in Docker. Nginx, as you may know, is a web server. So to begin with, if you navigate to hub.docker.com, this really is the registry of all kind of known container images. And if we just search for Nginx, all right, so we have several results. We want the official build. You're usually best to go with an official build of something because, any other build that's out there, you don't know what's in there. You don't really know what that person may have included in that image. Is it up to date with its OS? Are all the libraries patched to the latest security standards and all that stuff? So always best to use official images if you can. So I'm assuming you've already got Docker installed. If you don't have it installed, go ahead and download it on Windows or Mac OS. It actually runs through a VM, but that's okay. If you're running natively on Linux, that's great. This demo is all on Linux, but it should work the same no matter what you're running. Of course, we go look at the Nginx image. Right off the bat, they give me this suggestion for a command. If I copy that and I paste it into a terminal, what this is going to do is it's going to go and download the Nginx image from Docker Hub. Now, I happen to already have it downloaded. You may not have it. You actually don't need to do a pull on these images. When we actually run them, if you don't have them, it will automatically pull them down from Docker Hub. And usually in the reference for any official image, there is some decent information about how to run an image. So they do have a little bit about how to run it, but we're just going to go through step by step to demonstrate some Docker concepts, okay? So what if we want to run the thing? What you do is you run docker run. I always usually use -d. Like that means detached. I'm going to run this in the background. And I typically give my containers a name. So we're going to call it my Nginx, and we're going to run Nginx latest. See, we pulled the latest tag, so that's what we're going to run. And there, it's often running the container, and this long string here, that's the container ID, but you don't need to write that down or remember it. You can always run docker ps to see what's currently running. So you see, I have two containers running right now. I've got this sync thing guy, but I've also got my Nginx, which I just started. And if you'll notice, this FC, this is the first few letters of what that image ID was, the container ID, I should say. You can always reference your containers via either the container ID or the name, okay? If you don't specify a name, it will auto-assign a name. I like to assign my own names just so I can keep track of them. So, okay, so the image is running. What is it even doing? So you can always look at the logs for a container by using the docker logs command. So docker logs -f is follow. Just like when you tail logs, you can follow. And you can either specify my Nginx or you can use this ID. And what's interesting is you don't even need to type the full ID. You can just say fcd. As long as nothing else matches that, it will work. So here's the last few lines of the log for my Nginx server, and it says it's ready for startup. I think it's probably running. I'm just going to hit Control-C to get out of the logs. So that's showing logs. Can I do anything else with this thing? What's actually going on inside that container? And we said it's kind of like a VM, so I should be able to get into it, see what that OS is doing. And in fact, you can always run docker exec, which is execute, -it, which is like interactive terminal. I just say execute it is kind of what I think of in my mind. And you say which container you want to execute in. We're going to execute in my Nginx. And then you get to say what you want to execute. Well, I want to get into my container as if I was SSHing into it. I could just run bash in the container. And if I run bash in that container, check it out. My prompt has changed because now I'm running bash inside the Nginx container. And there you go. This is the root file system of that container. It's not too interesting. I'll just exit out of that. And you see I'm back into my host machine. I can't really do a lot with this right now because I need to forward some ports. So let's get rid of it. Docker rm-f is force. Okay, so that's gone. Now what if I actually want to use that Nginx server? We go back to the how-to on the Nginx page. They talk about exposing an external port. So here's another option on the Docker run command. It's -p, which is a port forward. Okay. So what they're saying is they're going to forward port 8080 on the host machine to port 80 inside the running container. All right. And I've actually done a diagram for this just so we can kind of understand what's going on there. So our container apparently runs on port 80. Okay. Nginx runs on 80. That's the normal HTTP port. But that's exposed inside the container only. We need to expose that out to our host machine. So we need to set up a port forward. So this 8080 is running on the host machine. And if anything on the host machine hits 8080, it will forward into port 80 in your running container. So why don't we try that? We're going to do docker run again, -d, so detached. And I'm going to do a port forward. I'm going to say 8080 on the host. We'll go to 80 in the container. I'll give it a name, my Nginx again, and it's going to use Nginx. I can say Nginx latest, or I can just leave it off. It's implied if you don't say to use the latest image. Okay, we get a different ID because this is a different container. It's based on the same image, but it's a completely different container. If I do a docker ps again, you'll notice now it's kind of a little bit difficult to read, but ports right here, this is saying forward from any client at port 8080 to port 80 using TCP. So does that work? Yes, it does. So here I've drilled into the container essentially from my host machine. So this is the default Nginx, welcome to Nginx HTML page. And if we go back to the Docker Hub instructions, you notice they talk about this volume mounting. Well, we're going to go into detail on this in a moment, but they're talking about this directory, user share Nginx HTML. I would guess that that's maybe where this is living. So we can verify that by doing a docker exec. We're going to go into my Nginx bash. So there I'm inside the image. And you remember it was user share Nginx HTML. Okay, so I have a 50x HTML and index. Let's cat the index. And there we go. Welcome to Nginx. If you see this page, it's up and running. So that's that. So of course, if I really wanted to, I could manipulate this. Now normally I would run vi and hit the index.html, but look, vi is not even installed. You can always do apt update and apt install vim. Maybe I'll say yes vim, and that'll go and install vim so that then I can edit files directly. Now it's worth noting that I'm installing this in my running container. If I destroy the container and create a new container from the Nginx image, of course, this is not going to be there again. So if I go and edit index.html and just say well, I'll just put some exclamation marks here. So I've updated that. I reload this. So there, it's live. But here's the thing. I leave this. I do a docker rm f my nginx, and then say I recreate it. Of course, it's based on the same image. That image doesn't have VI installed. It doesn't have the index.html modified, so it goes back to what the default was. So what we would normally do is we wouldn't really use this default index.html. Now I have a GitHub repo set up. If I just go to it, and I'll put a link to the GitHub repo in the video description. But in here, of course, I've got a README that's saying all the things I'm telling you. But I've got this site. And in this site, I have an index.html. There's really not a lot to it. It's just, this is my content. Not very interesting stuff. If you clone this repo, we can set it up so that we can get this. Maybe I should just open this with VS Code. Okay, so this is my content. So what if we want to use this instead of that default index.html? Again, we go back to the nginx instructions here, and they're talking about doing a volume mount. So what this is going to do is, just like we saw the port forward where we forwarded port 8080 to port 80 inside the running container, we can volume mount, we can mount the file system of some location on the host machine to some location inside the container. Okay, now they're saying mount it read-only. I don't care about that. We'll just mount it directly. So what you can do is, I'm going to remove it. We're going to run. Again, detached. We'll do the port forward 8080 to 80. And then we're going to do a volume mount. Now, this is pretty deep into my file system on my machine. I'm just going to say present working directory. Of course, you could do a full, like if you're running on Windows, you can do C, like my directory, whatever. On Linux or on Mac OS, you can just say present working directory. And I'll say site. So we're going to mount the site subdirectory. And we're going to mount it to user share nginx HTML. We'll give this a name, my nginx, and we're going to be running nginx. Run that. Okay. Let's go reload the index page, and this is my content. So that's kind of interesting, and this is truly volume mounted. If I change the file on my host machine and I reload it, you notice it's instantly live, and we can even have a look at that. I'll go to user share nginx HTML. And there you go. It's actually this location inside the container really maps out onto my host machine. So if we look at that image that I had created earlier, so we've got the port forward going on, but there's also this volume mount that's mounting out to the host machine. So of course, since that's volume mounted onto a directory on my host file system, it will survive container recreation. So if I go ahead and remove my nginx again, and then I can recreate it with the same volume mount in place. And when it's back up and running, of course, I can reload this and it's still there even with my latest revision. So you would really use a volume mount for something like a database server, for instance. You don't want the data in your database to go missing if your container goes down or you need to replace it for some reason. So it makes sense that you would do a volume mount to where the data is actually stored. You can do quick backups of the data itself and so on. But for something like nginx or even any application you're creating, you're probably going to want to put your content into a real Docker image so that when I run it every time, I don't need to do a volume mount. Let's say I've created an application and I want my colleague to be able to run it easily with a Docker run command. I don't want to have to force my colleague to go and clone some Git repo in order to mount on top of my content. If my content's HTML, or if it's some Java like Node.js, or it's a bunch of Java jars or something like that, I just want the Docker run command to just work. So this is where we can create a brand new Docker image based on the Nginx image. Okay, so we could bake the site directory into a newer Docker image that I create. We look at VS Code, again, the contents of the repository that I mentioned. You can create a file called Dockerfile with a capital D. And this is basically a build file for Docker images. Okay, so the very first line you typically give these is the from keyword saying, hey, I want you to build my image based on or from Nginx latest. As I mentioned, you probably always want to build based on an official image so that you know exactly what's in it. Now, I've shown a few additional things in here that you might include. Like you might say, yeah, this image is going to expose port 80. This actually has no functional difference, I believe. This is more for documentation. I've commented it out because it actually inherits this from Nginx latest. The run command lets you just run things as if you're running them in bash. Okay, so I like to have Vim on my image. This here is the secret of what we're going to do. We're going to copy the contents of site into user share Nginx HTML. So it does a full-on copy. It's not going to do a volume mount. The files are really going to go into the image. And typically at the end of a Docker file, you would have a CMD, which is, here's the entry command that I want you to run. This is what I want you to run on startup. I don't need to specify it again because I'm inheriting it from the base image. Now, what may be more typical, if you have your own application, you might copy in a shell script that actually does the execution of your application, and then you would run cmd to actually run that shell script that you've copied in. So this is the build file for the Docker image that we'd like to build. So what you do is you say Docker, so you have to be in the directory of the Docker file, which I am in. You say Docker build, and -t is tag. So we're going to tag the image we're going to build with a name. We'll call it my Nginx, and I'll give it a tag of latest. It's just convention. And you have to tell it what directory to run from. So I'm just saying run from my current directory. Okay, and you run that. So that was pretty fast. Here I actually hit the cache. It may be slower for you because when it does the apt update and apt install, it will actually go in to download off the internet. So it built my image, my Nginx latest. So let's look at Docker PS again. I'm going to do a Docker rmf my Nginx. Now I'm going to run my new image. Remember, my image, I named it my Nginx latest. We'll say Docker run detached port forward 8080 to 80. I'll give it a name, my Nginx, and we're going to run it based on the my Nginx latest image. Remember, before we were running based on the Nginx latest. This is my Nginx because this is the image that we just built. Run that. This won't be too interesting because I'm going to reload this again and it will be exactly the same. But now it's based on the image that I just built. So you would typically create a Docker file for any application that you would create. And an application is typically more than one thing. You're likely going to have a database or something in behind your application, and you need these two containers to talk to each other. So in order to do that, I just want to go over briefly how Docker networking works. Okay, you can say Docker network ls, and this shows me all the networks that exist for Docker. What Docker does is it allows you to create these bridge networks that kind of act as if they're their own little physical router with their own little subnet. What we're going to do is we're going to do a Docker network create, and we'll name it something. Let's say mynet. So Docker network ls again. There's my net. I just created it. What I want to do is I want to put several containers on that mynet network. So I'll do a Docker rmf my Nginx just to get rid of it. And I'm going to recreate it on the mynet network. So what you do is network mynet. So we're going to have to put a different container on this network just so that we can see how they could talk to each other. So why don't we go and grab a database, Postgres. How about that? Again, official image. Usually you go down and they give you some command on how to run it. So there is a Docker run command. I'm going to use that. I'm going to modify it a little bit because I am going to also add network, mynet. Okay, before I run it, just want to go over the command again, just so you know what all is going on. We're giving it a name, some Postgres. We're putting it on the mynet network. This -e you haven't seen before. This is an environment variable we can pass in. So this Postgres password is going to be available inside the image, or inside the container, I should say. And we're going to run in detached mode, and we're going to use Postgres or Postgres latest. Okay, for you it likely would have pulled the image. I already have the image. Let's go into the Postgres container. Well, we'll look at Docker PS. So you see that it is running some Postgres in my Nginx. We'll do a Docker exec some Postgres going in with bash. So I'm inside the image. By the way, echo you see we provided an environment variable at the run, and it's actually available inside the running container. And Postgres must use this environment variable on startup, so when it creates the database, it actually sets the password to that. This is how you pass things into containers, by the way. When you're first created, they typically will read a bunch of environment variables to set whatever conditions are required for that container in that environment. You might have database passwords or database URLs that you want to connect to and so on. Anyway, I'm inside the Postgres container. So normally I would do a curl on my Nginx port 80, but it's not working because curl's not there. So let's do an apt update and apt install, yes, curl. So curl my Nginx port 80. There's my content. So let's talk about what just happened there. That's the URL that I pulled down, my Nginx 80. Now, a couple things. First of all, it knows about the other container based on its container name. So I can just hit my Nginx and it knows exactly where that is. It's like entering mynginx.whatever.com. It knows exactly how to find it. The other thing is I'm asking for the content on port 80. These are both running inside the same Docker network, the mynet network, and they see each other as they actually are. So the Postgres container sees my Nginx based on its name, but it also sees all services that that container provides on the true ports that they provide. Okay, just to describe what's really going on here, we have two containers running inside a network. They're both in mynet. They can see each other based on their container names. I should have maybe named this some Postgres because that's how we created it. So my Nginx provides a service on port 80. It provides, that index.html file. So Postgres can get that directly on port 80. After all, it's running inside that network, so it can see this other guy running on its native port. But that port 80 is still forwarded out to 8080 to the host, to the real world. Okay, so if we did a curl to 8080, it wouldn't work because as far as this network is concerned, as far as my Nginx is concerned, it's got nothing running on 8080. The only reason anybody knows about 8080 is because we've got this mapping out from the host network to the internal container, port 80. However, what we can do, this is a little weird. You can actually contact the host machine from any container. So Postgres can contact port 8080 out running on the host. Okay, so on this diagram I've said host.docker.internal 8080 or 172.17.01.8080. This depends on your OS. If I did host.docker.internal 8080 on Mac OS or Windows, this would work. Since I'm running natively on Linux, I need to say 172.17.01.80.80. This goes all the way back out to my host machine and hits 8080, and it has gotten back to my Nginx through a very roundabout way. Look, you wouldn't normally do this. You wouldn't normally go out to the host machine to go and get something. I just included this here because it's a nice little debugging trick. If you're messing around with containers and you're like, oh, I've got that thing running on port 30,000 and I forgot to put it on the same network, you can always get out to the host machine and hit it in a temporary fashion until you've fixed it for real. But typically you'd always run these inside a network, and they would talk to each other based on their real names and based on the real ports they're running on. So that's really everything I wanted to show you guys today. It's a lot of work to do all this poking around in the command line, Docker run commands, Docker RM, Docker network create. There's a lot involved there. And, it's not great to be able to have to go and do all that yourself. Wouldn't it be nice if there was some way to orchestrate all this, some other tool that could handle all this for us? In fact, there is. That will be the subject of the next video. Thanks for watching. See you next time.